hope you had a good party and some sleep. If not, you can get some sleep now. I will not be distracting. So my name is Jacek. I'm a storage infrastructure architect. I work for NETAPP. And this is my best friend Mike. That's the joke I have to make every single time, sorry. So as you can see, I like to use acronyms in my title. So HCI for BCA, that's what I'm going to speak about today. So obviously HCI is Hyperconverged infrastructure. This is the new hot thing in IT, or at least this is what reached our markets. And BCA is a business critical application. So that's what I'm targeting. So if this is not the session you wanted to come, you can still reach the other one. Okay? Nobody? Good. All right. So what we are doing, if you never heard before who NETAPP was, sorry, one more thing. So this is in IT Congress there are two types of stuff: presentations and focus rooms, right? And presentations meant to be not so technical, and focus rooms are more technical. I don't think I can make any difference, okay? So I try to be not that deep, so give you ideas that what we do if you have no idea what Hyperconverged was, but sometimes I will go into the details, okay? So, if you never heard about NETAPP before, we are a data management company. So in total clearness, we are doing storage for about, I don't know, 27 years. We are currently the second biggest on the market in terms of external storage. And last year we decided to jump into the hyperconverged infrastructure market as well, so why not? In the past couple of years we built a quite big portfolio. We used to focus only on on-prem data centers and selling storage-based solutions and data management-based solutions for on-prem data centers. Obviously the growth of the cloud, especially hyperscalers, make the importance even more for hybrid cloud solutions. So obviously we are working with our customers to give them a possibility to move data between on-prem and public cloud, and between different public clouds and things like that. But what we are also doing, we focus on what we call the next generation data centers. So helping customers to figure out how they can, reallocate their resources and focus more on application delivery instead of operating infrastructure. So that's even more funny because I'm a storage infrastructure architect. I'm doing infrastructure in a world where infrastructure is less and less important. So I will see how I can figure out how I can move forward. Okay, so why we are doing this hyper-converged thing, or why we are, switching into different waters compared to what we are doing? Because, if you look at the stock and if you look at market details, we are doing fine. So we are growing nicely. Our stock price is like amazing. So why would we need to change to anything else? It's because the market is pushing us. So it's, if you ask me, I would work with ONTAP till the end of my life because it works, it's nice, our customers like it, it's reliable, it does what we need to do. But unfortunately, ONTAP is like other enterprise-based storage systems. They are like a pet. You need to take a lot of time, to deal with them. So enterprise storage and enterprise IT infrastructure needs to have enterprise operations. And there are a lot of customers who are moving away from this model. There are a lot of customers who say that, we have a basic idea how to operate basic virtualized environments. We have a lot of IT generalists who know how to create a VM and how to operate applications in virtual machines. We don't want to pay for like black belt guys who understand how enterprise storage works, and we want to free up those resources, and we want to make sure that they can focus on more important stuff. So this is what you see on the slide. You may catch this slide yesterday as well. This is what an average task, an average enterprise storage admin have to do every single day. It's 40 plus things, checking the logs, making zones and looking at access right and stuff like that. To make it even more clear, there's an average enterprise storage what a customer would buy today. There are 3 simple questions: how big, how fast, and who can access. These are the 3 basic questions I would ask if I pay for an enterprise storage, and without going to trainings and spending weeks, you cannot really answer these very simple questions. So that's the reason, and that's the push from customers for modern solutions like HCI, right? So first of all, what's a hyperconverged infrastructure? So who of you who already implemented either in production or in test a hyperconverged infrastructure? Okay, there's one. Who is planning to look at hyperconverged infrastructure? Okay, there's some. So what is a hyperconverged infrastructure? HCI is basically infrastructure, as the name suggests. So it's meant to be an end-to-end infrastructure which is capable to run your virtualized applications without adding anything else, right? So basically, typically, an HCI infrastructure is running typically on commodity hardware and basically using virtualized based services to basically run your application. So typically storage is virtualized, typically network is virtualized, and obviously compute is virtualized because that's why it's an HCI. Typically, HCI solutions go with the shared core model, okay? So that means that you take commodity servers with X amount of CPU cores, and the cores will be shared between the different services. So that means that your storage will consume some of the cores, your virtual networking will consume some of the cores, and obviously the VMs which run the actual applications are going to consume the core. So that's what it means, shared core service. But basically, it's meant to be easy, all right? So it's meant to be that you buy it extremely easily, you rack and stack, and 40 minutes later, it's capable to run your VM. So that's what a hyperconverged infrastructure is for. And obviously, like every single infrastructure piece ever since I'm working in IT, it has the promise pay as you go, right? Everything promises pay as you go. The only thing in the world which does pay as you go, that's cloud. So the bad news, I have to tell you already up front, there's no such thing pay as you go on-prem data center. There's always something you need to take care up front. So why is this whole thing happening? I spent a lot of years at the second part of the 2010s. We've been helping customers virtualize their applications. So we were a small company with a bunch of VCPs and VCAPs. And we were virtualizing customers who was not virtualized yet. And they were extremely happy because on top of VMware infrastructure, the management of their existing operating systems and the existing applications was much easier. Obviously, I didn't do anything on the VM part. I was migrating storage because someone got to do that job as well. But they were happy, And 10 years later, basically these virtualized infrastructures grew so big that the management of them is not so easy anymore. So this is where policy-based automation and policy-based management got into an extremely important into operating these environments. The other fact is consuming models, and I like to use this slide a lot because it describes basically the difference between different infrastructure pieces. So what we as a vendor did for 27 years is we were selling best of breed appliances. So we work together typically with partners. We can provide a storage part, and the partner does the job to help the customers figure out that, okay, which type of server, which type of storage, and which type of networking they work the best together. It gives you the extremely good cost to performance ratio. So this is what we understand really well. This is what our partners understand really well. So from this, you can go into two directions. So there's a lot of driving factor which pushes customers to go into different directions, become more, operational efficient, or cost cutting, or cost reduction, or and so on. So one of the obvious models to go in that direction and go to the software commodity, go all the way open source, get the commodity hardware, because all of those are cheap. The unfortunate fact on that side is that if you go all open source, then you need to put the brain inside extremely. So you can go the Facebook model and the Google model. You only need to hire the exact amount of brain what Facebook and Google have on a per core basis. The other direction you can take is you can go the converged, hyper-converged. Because with converged and hyper-converged, the infrastructure is simplified, so you don't need to think that, okay, which type of server, which type of storage works together, because you get a vendor guarantee. So with the converged infrastructure, you go a single vendor or maybe two vendors. They give you a catalog, okay, what you can choose from, and they guarantee for you that they will work together and they're compatible. In a hyper-converged infrastructure, it's even more easy because you have basically a single vendor. It's a black box and which has compute and storage, and that's it. You don't need to think that, okay, what would work with what together? Do I need this server or that server? Maybe that vendor works with this together better, or what's going to happen? And the easiest to operate is as a service. If you just go ahead, Office 365 or Google Mail or something, software as a service, it just works fine. You don't need to operate anything, you just create the users, the mailboxes, and that's it. On the other hand, though, if you look at the chart, the vendor lock-in goes this way, all right? So that means that if you have a best-of-breed appliance model, you can switch any part easily because it will still work. If you have a converged, you can still, replace some of the part of this and that, maybe a couple of new servers and stuff like that. It will probably still work fine. In hyperconverged, sorry. In the cloud, did you ever try to migrate from Office 365 to Google Mail? That's pretty hard. So the vendor locking goes this way. And also, if you look at typically the cost balance between the vendor and the customer goes this way as well. So this is roughly the directions. All right, so we started in hyperconverged infrastructure last year. I think we released the product around November. Okay, so the hyperconverged market started in 2009. So last year when we started, we were the 37th vendor on the market. Did we start early? Not really. We start pretty late, just like in Flash. So why we started in hyperconverged infrastructure after being 36 more or less successful vendors out on the market? Because we felt that we can add some additional value. So I call this the Microsoft innovation model. You look through a market, you feel that, okay, the market has potentials, you figure out what the others doing not so well, and you try to fill that gap. So this is what we are doing with our hyperconverged model. What we are focusing on is guaranteed performance, because what we are doing is we are trying to look for enterprises who run. So enterprises, I'm not necessarily mean the size of an enterprise, okay? So you don't have to be big. With enterprise, we typically mean the enterprise type of applications. Databases, maybe Exchange, some messaging services, average enterprise applications. So we looked into the market and we figured out that there are a lot of customers who are looking for hyper-converged infrastructure because they like the value of the purchasing model, the support model, the way to extend these environments. But most of the solutions currently out on the market doesn't help the enterprises isolate their workloads from each other. So this is what we are looking for. So we said that, okay, we could build something which provides guaranteed performance per virtual machine, so you can basically provide guaranteed performance per application. We never sold servers before, so I thought it would be a good idea to show you how it looked like, because we are mainly a storage vendor, so how may it look like that if we are coming out with a server. So yeah, we need to go back, and I had to learn what a core means, what memory means, how virtual machines look like, and stuff like that. So basically what we do, we build this two-unit appliance. This two-unit appliance has 4 physical nodes, and basically the 4 nodes can be storage or computing, basically any combination. So there's no strict way to populate these nodes. It cannot really get any simpler than that. So let's look at the big picture. So the big picture is that we decided to not do a lot of things what other vendors are doing. So we looked into to the market what others are doing, and obviously we figured out what we would want to do. So number one thing, we only work with VMware. Okay. So we looked at the virtualization market, and the virtualization market has 93% VMware currently. So we said that okay, it would be more than enough today to just work with VMware. We have plans for the futures, obviously, but as of today, the only thing we do is VMware. The second thing is that all of these services, so obviously as we do storage for 27 years, we have an idea, and we have storage services which we can use. So we had basically 3 types of storage services internally to employ. So we just had to choose the best one for our hyperconverged infrastructure. So obviously, if you have an existing storage piece, we already have the data services available. We're replicating to a secondary side, replicating to a third side, replicating to, I don't know, 256 side, replicating to the cloud, back from the cloud. We can do all of these already, so these are not challenging. The interesting thing is that if you look at the other hyperconverged vendors, most of them are coming from the compute or from the virtualization part, and they had to figure out how to build the storage. We are coming from the complete opposite side. We had the storage piece already. We just had to figure out how to build it together with simple commodity compute nodes and just use virtualization because it works fine. If you had my presentation yesterday with VMware, we worked together with VMware since 2002. So we supported already the first GSX release. So we have a pretty good track record how to work with VMware and how we build solutions with them. So let's see a demo. It's 2 minutes only, so I'm pretty sure you will survive it. All right, so what I said is that, all right, so one of the requirements on a hyperconverged infrastructure is get it up and running quick, okay? So this was the first thing we wanted to get done. So basically what you will see here is basically the kind of the new product in this mixture. It's called the NETAPP deployment engine. When you purchase a hyperconverged infrastructure, you rack, stack it, you power it on, and this will be the screen which basically welcomes you. So when you start this whole thing, we will get, obviously, we have this get started button, and basically we go to the licensing page, and you need to accept licensing. Now there's something very important here. So there are 2 licenses you need to agree with. One of them obviously the NETAPP one, the other one is the VMware one. So we do not sell VMware licensing, okay? So what we do is we take the HCI and we ship it with the demo licenses, which the ESXs are coming by default, but we decided not to sell VMware licenses. Most of our customers have VMware licensing already, so they don't need them, or they can purchase it from the partners they are buying the HCI from. Okay, so once you agreed with the license agreements, then basically you need to decide if it's going to be a new VMware infrastructure or going to join to an existing one. If you join it to an existing one, you can simply type in the IP address which the vCenter will use, or if it's already in the DNS, you can just type in the name. You need to set a single password. So this single password will be used everywhere. So this will be the plugins, the vCenter, everywhere. We obviously have a guide, so if you want to change the passwords after the implementation, then basically you can do it. But basically this replaces a lot of password boxes, so you don't need to deal with that. And the last thing you need to do is to fill out the IP addresses table. There's two ways to do it. One of them is the basic. With the basic, you need to provide two networking, one for the management, one for the storage, with basically network details. And obviously, when you fill this up, everything will be checked. So if you type in something to the DNS and that's not DNS, we will tell you. If the IP address is used by something else, we will tell you, and so on and so on. So this is pretty basic. You just go ahead and fill up to network address domain. That's it. If you wish to do the manual way, you can click on the manual tab and you can fill up every single ESXi and every single storage node and every single one of them manually. So once that's done, this is where the job comes. 35, 40 minutes later, it will be basically up and running, and you can go ahead and connect to the vCenter through the web interface. So that's it. That's the installation of the hyperconverged infrastructure. So this is what it does. It means to be run virtual machines 40 minutes after power on, and it's capable to do that. Any question at this point? No question. Okay. So I said we made a couple of decisions because we had the pieces together. We just wanted to build this and do a packaging and do the installation. So one of the decisions we made. All right. So we had the storage piece. We had 3 types of storages to go with, and as I mentioned earlier, the hyperconverged infrastructure is meant to be a shared core model. So you have individual servers, and all of them are running storage services, VMs, and networking. So we decided to not do that. So we said that, okay, we have storage operating systems which can run either in a VM or on a physical host. And we looked into the pros and cons to run the operating system of the storage in a VM compared to run it on a physical node, and we decided that, okay, we can deliver more value if we just keep it on a physical node. So basically what we not do is we not run the storage in a VM, we just run it. The compute and storage nodes are very, very similar, but they either run compute or run storage. But this part is going to allow us to get the maximum performance out of the hardware. So basically, if you virtualize the storage node, it would just take away from the performance, and we will not be able to guarantee the same level. So what we do is that every single time when you create a virtual machine on the hyperconverged infrastructure, at the creating time, you need to specify that what is the minimum, the maximum, and the burst performance of that specific virtual machines will do. And this is how we guarantee it. So there's 2 ways to do that. So this is the traditional model. The traditional model is the good old way. ESX does storage for, I think, like 15 years. Okay, so you have a single data store. On the single data store, you run a lot of virtual machines, and they consume storage together. So we work together with the VMware API. We use the storage I/O control. You define the performance characteristics per VM, and we will deploy this on the aggregate level, on basically the aggregated data store level. Most of the customers are going with the vVols model, though. So if you are looking at the hyperconverged infrastructure, which is meant to be a next generation infrastructure piece, and next generation storage technology is pretty much acceptable. So if you go the vVols model, then basically every single VM inside the HCI is going to have its direct storage objects. So from the storage part, we can guarantee the minimum and maximum performance for that specific VM. Okay? From scaling perspective, obviously we can scale from small to large. Now there's something very, very interesting. I see a lot of cases that hyperconverged vendors say that, okay, we can do this and we can do that. And there's an analyst report done by, I'm not sure it was Gartner, but basically they looked into scale-out vendors. And most of the scale-out vendors has an issue of scaling beyond 20, 25 nodes. And the reason for doing this is that in a scale-out model where you have a lot of storage nodes discussing things in the background, the metadata conversations will be so big that basically the storage part cannot handle it. So that's why we decided to take this operating system. So what we used here is we have this SolidFire platform, and the SolidFire platform has been built specifically for service providers a couple of years ago. And basically it is able to grow to 100 nodes without scaling issues. So we have customers, service providers in productions with 100 nodes running their clusters, and they don't have an issue with the scaling. So that's why we decided to go with this model. So from the node perspective, we sell small, medium, large, so t-shirt sizes from both the compute and both the storage. So obviously the difference between them, if you look at the compute node, the difference will be that how many cores and how much memory you will get to run virtual machines. And in terms of the storage sizes, again, small, medium, large, the difference will be how much capacity you get with the storage nodes and how much performance you can dedicate to run your applications. So the smallers are coming with 50K IOPS per node. The large is coming with 100K IOPS per node. So if you do the math, it's not small, all right? So if you start with a 4 storage node configuration, you are going to have an all-flash storage with 200,000 IOPS. That's pretty big. It's not necessary that you can use that storage performance inside the hyperconverged infrastructure. So I will answer this aspect later. From scaling perspective, this is the minimum configuration. So basically our minimum configuration is 4 nodes to get high available storage up and running, and 2 nodes to get high available VMware configuration up and running. So basically in 2 chassis we need 6 nodes to get our clusters up and running. So basically it means that if you deploy additional compute nodes, 100% of the cores and the memory are going to consume by VMs, so you don't need to think of extra tax or extra services that, okay, how much percentage of my compute node is going to consume by real VMs, it's going to be 100%. When you add storage nodes into the mixture, your capacity is just growing. So one thing to mention, in the storage part, there are no RAID groups and aggregates and stuff like that. All these storage nodes in the configurations create a single pool. So basically, you just look at a single capacity and single performance pool. So when you add the new node to the configuration, it will just grow the existing pool for capacity and performance. Okay, so basically the reason we decided to not go with a virtualized storage model because we wanted to avoid what we call the HCI tax. The HCI tax is when you run the storage piece virtualized, so you have to actually purchase VMware licenses to be able to extend your compute part. So this is what we not wanted to do. And also the other thing is that if you run storage service in a virtual machine, that means that every single additional storage feature, what you do with deloop, compression, erasure, coding, this will all increase the basically the resource consumed on the VMware side. Okay, so as I said, we have the NETAPP deployment engine. Day 0, you turn on the box, you get to the screen, next, finish. 40 minutes later, you get your infrastructure up and running. So what the NETAPP deployment engine is doing, obviously, it creates the storage, it creates the ESX clusters. Basically, it will deploy the vCenter appliance. If it's a new infrastructure, if it's an existing, we will just connect to an existing one. We have the Hyperconverged infrastructure plugin. It will basically employ the management agent and the monitoring. The reason we are doing this because we just use the vCenter as the monitoring. I will talk about this later. And also the additional thing we do, we have a plugin which can use cloud-based prediction and monitoring kind of analytics. For day-to-day management, that was the other decision we had to make. So in some of the cases, some of the HCI vendors, some of the HCI vendors, they build a new GUI for the management and the upgrades and monitoring and things like that. We figured out that, okay, we are going to work with VMware customers. VMware customers already know well how vCenter works, so we just use vCenter for the management. So obviously, if you use vCenter for the management, you need to make sure that every single storage feature and additional things like logs and monitoring part is inside VMware pretty well. So basically that means that what we did is that 95% of the storage operations are done from vCenter. The only thing you cannot really do from vCenter is, for example, if you want to take out a storage node from your storage cluster, you cannot really do that from the vCenter. But basically what we do is that the event logs of the storage, the monitoring logs of the storage are going to the event log of the vCenter. So when you are looking at the vCenter event logs in a chronological order, then you will see basically the VMware stuff and the storage stuff together, so you can do a real troubleshooting. And the other very important part, what we looked for is the automation. So the way we are doing automation is that we have a part of the GUI where we help admins to figure out how to get started with automation. So what we do is that, for example, when you create a new VM, you click together you want to do, and basically the GUI is going to give you a code, for example, in Perl or Python or PowerShell, and then you can use that code to insert into your existing scripting or existing automation, so you don't need to figure out that, okay, how our API works, and where is our SDK documentation and stuff like that. So that's basically a kickstart for the automation model. And basically the last piece is we do what we call an open compute, an open storage model. So as I said, if you build the smallest possible NETAPP HCI, the smallest possible NETAPP HCI will come with 200,000 IOPS, and that's pretty big. So we decided to let customers to use the storage part of the HCI with things outside of the HCI. So it's a totally standard iSCSI. So you can use a standard 10G network or 25G network, and basically you can through the external switching, you can, if you have an OpenStack environment, if you have a KVM environment or anything else than VMware, you can just use through iSCSI, you can create LANs, and you can do exactly the same value that inside the HCI platform. So the difference between these two, that on the HCI, you use the NETAPP deployment engine, you get the HCI value, the infrastructure is up and running after 40 minutes, you get a complete VMware infrastructure, you can deploy your VMs, it's pretty easy to use. Outside of HCI, you get a standard iSCSI interface. So you just go to the storage GUI or through the API or through CLI, you create iSCSI LANs, you basically map them to iSCSI clients, and you can run OpenStack or VMware. Generally speaking, the storage piece, when it's used outside of HCI, we are focusing mainly on KVM, OpenStack, and VMware environments. So basically, we have plugins, for example, OpenStack Horizon. So it works very, very similar to vCenter. When you create OpenStack-based services, the OpenStack is going to provision the storage through the API without going to doing anything manual. Any question about that? No question. Okay, one thing I forgot about the networking. So for the first model, we decided to go with 10/25G. So basically based on the SFP and the networking and the cabling you are using, you can use any of these. And we work with bring your own switches. So we don't add physical switches, although we sell some of the switches for our environments, but basically the hyperconverged infrastructure is not going to arrive with a switch, so we expect a customer to have already some sort of networking infrastructure, so we don't want to force our decisions how to build the networking infrastructure. You probably have your own working really well. So, summarizing this whole thing, we did a lot of decisions to build our HCI the way we build it. Obviously, a lot of our competitors say that, hey, this is not really an HCI because you don't do this and you don't do that. There's not really an industry level of specification what hyperconverged is. There are requirements you have to do as a vendor to build something what you can call hyperconverged infrastructure. Basically, we feel that what we did can deliver what the hyperconverged infrastructure have to deliver, and we try to look into the unique values what we can deliver, obviously. So number one, we looked for guaranteed performance because we wanted to make sure that the customers can run individual applications with the guaranteed performance, uptime, availability, and so on. And the other thing we looked at is flexibility and scaling. So currently, the limits of scaling, you can use up to 40 compute nodes and up to 32 storage nodes. So this is version 1. We came out in November, so we have a 6-month or 7-month track record shipping and selling hyperconverged environment. So far, our customers are happy and they are liking the product. Obviously, we are going to improve on scaling and we will do change. This 32 storage nodes and 40 compute nodes is pretty big. So if you do the math, how many cores you can get and how much storage performance and capacity you can get, it's pretty massive. And the third thing is automation. And so finishing this whole up is that obviously we don't have to fix replication, data management, and different type of issues because we just simply reuse an existing storage piece. We put it together with VMware, and basically we have all of those available. So replication, synchron, asynchron, from hyperconverged to the SolidFire platform works. Asynchron from hyperconverged to ONTAP works. Thank you. From the hyperconverged infrastructure, we can directly back up into S3, so you can use Amazon Web Services to directly back up your data. You can replicate to Cloud ONTAP, so you can do DR in the cloud, and also we work together with backup vendors to get application-aware backup. The first vendors we started with are Veeam and Commvault, basically. Okay? Any question? All right. If you don't have any question, you can reach me at the Logicom NETAPP booth. You can find me till the end of the day. I'm very lucky to be able to present the 5 p.m. session today, so if you are interested in other NetApp stuff, you can come there. As I said yesterday, I will not have a dinner in the session at 5 p.m., so if you want to come to the 5 p.m. session, you have to come with food, because it will be pretty late. But you want to stay anyway, because the tombola or what will be after the 5 p.m. session, so anybody who is interested in cold storage solutions, very, very welcome to come, and thanks for your attention, especially in the first session in the morning after the party. Thank you. Have a great day.